Good day, everyone. Today we are going to continue from the last session. Last session we have touched upon the knowledge base, leveraging knowledge base using a structured data. And we have seen how to use a Redshift, serverless, and load the data from there and retrieve the data using a natural language prompt using uh, Bedrock knowledge base. And just before jumping to the today's session about the GraphRAG, we are going to touch upon as we discussed last session. Quick recap: we have touched upon what is Amazon Nova and what is knowledge base. Then what are all the new releases from the Bedrock knowledge base last year, and what we have in this year. We have touched upon the structured data retrieval. That's what we have touched upon. Today we're going to be touching upon the GraphRAG. And we have seen what is a scalable RAG application methodology look like with a continuous improvement, what are all the things you need to consider. And today about the GraphRAG. First, what is GraphRAG? When to use the GraphRAG? If you have a multiple documents or the multiple data source and where that data information is dispersed into multiple places, if you want to find the relationship or entities between the document, which is not clear, you can use a GraphRAG. Example of a fraud analytics. Okay, people may have, you can identify, and the loan approval. Okay, you can say multiple documentation, multiple parameters, and multiple data sets we have where you can use the person ID or his profile to come to the conclusion. Okay, and the summarization. If you have multiple documentation and if the entities are more, the summarization will be faster if you are using a GraphRAG. Let's see why it is. Okay. And what kind of graph database option we have in our Amazon is we have a Neptune database and we have a Neptune machine learning and we have Neptune analytics. Okay. And in the Neptune analytics is what we are going to look at it. And the Neptune analytics is tightly integrated to the knowledge base, Bedrock knowledge base. Okay. And it is serverless. It priced on unit, like how we have touched upon the Redshift. This is also serverless, but it is not on a free trial. Please have a glance, check it before you do the pricing. Okay. And searching in a vector database, right? Whenever you are searching in a vector database, it will compare, it will use a cosine similarity. You convert the text into the vector and keep it into the vector database, and or image, you convert it and put it in the vector database using embedding model, then it will find the cosine similarity and figure it out. What is this one? And if you want to have multiple similarity for the same one, you need to have a better way rather than the vector space alone. That's where the graph spaces come into the picture. Okay. And it will take the data and extract based on the entity, and then it'll have a relationship with the entity and store into the as a graph. So when you are asking some question like how many fraud transaction happened in so and so location, so it can go traverse upon multiple data source and check fraud as the one and gather all those things, and you can drill down up to the zip code based on, I'm just giving an example. Okay, so the graph will work better during that kind of use case while you are connected. And how the GraphRAG combine with the vector database. So same thing, you have your data source. Currently, I have kept 3 data source. For the fun part, I used a lot of the rings and from epic drama, epic story from Indian mythology, Mahabharata. And then I have taken some fraud case from the Bernie Madoff case, the Ponzi scheme. Okay, I taken all the data and I loaded the data into the vector store, and knowledge base, with the knowledge base, it automatically stored the database. So the graph is currently analytics. We will want to look at it. When I ask for the question, right, it find the, what is the entry point or what is the entity related to this one, and find out what are the nodes it has and what document it is related. Then it will give that particular prompt along with the prompt we have given with the extraction taken from the graph. It will be give it as an augmented information to the large language model to get the response. Okay, so that is how the GraphRAG work. Okay, if any I found some interesting article. I'm gonna show that for the GraphRAG. Okay, so the picture is really helpful for me to have a better understanding. Let me touch upon that particular one. Okay. Okay, this is what, okay, this is noted by the Akshay. Okay, so this is it's really, I really like this one. It's very intuitive. So what happened, right? You can use the when additional document is there, it will generate the graph, identify the entity and relationship, and then it use the embedding model and load to the graph database. This is about storing the data. Okay, up to 1, 2 the entity, then embedding model and storing it, and from the relationship storing in the graph database up to 5. Then when the user query, right, it uses the same embedding model, take a similarity search, and get the relevant and get the we traverse to the graph, get the additional contacts plus the query. So you get the contacts and the nodes and entities relevant to it, and do the query. All this information will be prompted to the large language model for the better response. So if you want to have a multiple document, if you want to traverse through the multiple relationship, this will fare better than the vector database where every time you need to go for a cosine similarity. Okay. That is what the GraphRAG, I really like this one from this Akshay Pasher. I like to share with you people so that you have a better understanding on it. Without further ado, let's get into the lab. Okay. So you go create, use a vector store only. Under the vector store, you can say sample graph, something like that. Then you can select something, the S3. I have stored the data into the S3. Okay, I can show you this one. So I have demos, Bedrock database. So I have 3 different element. I told you, right? A lot of rings and everything. Okay, so we can have a characters based on this one. So cancel it. I choose it. Oh, sorry. I need to select something. Okay, let's select something. Demos, Bedrock, database, and lot of rings. I can see it's a fellowship of the ring is the one I have selected. Next. Okay, here, this is what happening. It use a parsing strategy. It use the Bedrock default parser. If you want to use an additional foundation model, Sonnet models are available. Okay, and you can do the what kind of parser you need to do. You can give the instruction, so it will be parse it before storing it. Okay, then next, I'm using a same Titan text embedding model. As I mentioned, Nova model is really good, but still we are using an embedding model. Nova, there is no embedding model under the Nova family. Okay. Then I'm using a Neptune Analytics. So you can, if I already have it, you can select the particular Neptune Analytics graph database. I already have it created, but if you want to create, you can just create this one. That's it. You can click on create review, review and create. It will take some time, easily take 40 it take in 30 minutes. For the interest of time, I already created it. So this is a graph knowledge base we have. So you can see the embedding model is Titan embedding model, and I have a 3 data source. Okay. And then I have a vector. This is a vector database, and this is the database it is created. Okay. So I come to the vector database. Oh, sorry. So go to the vector database, Neptune. So come to the Neptune. Under the Neptune, you have graph. It automatically created. Only thing I made a changes. Currently, it only available as a private. I want to test with some notebook. So I modified it, modify and allow your graph to be reachable over the internet. It's not a best practices, but just for the demo, I'm using it. I told you, right? It's based on the capacity unit based pricing. Okay. So I'm using the least option available. Okay. Which is automatically created by, as I mentioned, by the knowledge graph. So after that, I came here creating the notebooks, I want to first see the data, how it is. Okay. So the data is very raw. Okay. Let me show that data, how it look like. So document. So this is some PDF file. Okay. See, this is around, say, let me, I'll stop share. Share, you share desktop to share. So if you look at it, this is what we have. There's a lot of things. It's around 575 page, and it has a full story. And then I taken from the FBI, the Benjamin. I just loaded all those data. Then what I did is, this is just a simple database. Okay, as I mentioned in this LinkedIn post, what is first happening is to take this additional document and it uses the encode option in, and then it is it is using a graph generator using the parser, and it finding the entity and relationship and storing in the data database. Okay, and again it is using the embedding model for the encoding. So how do I know how it is stored? Okay, that is why I want to use this particular way. This is the notebook I have created. So same thing, you guys can come here, create a notebook and connect to the particular database. If you look at it, it is connected to this particular database, and I open the notebook, and this is what you have. If you want to have something like a Jupyter Lab or something, feel free to check it, but I want to use a Graph Explorer. So I came to the graph, and if you go to the graph, okay, let me go to this one. Okay, open Graph Explorer, you can try it. So clear. Okay. So you can see this is a entity you have. Okay, let's say entity. So if I click on entity, right? So it is extracting the entity. Okay, if I click on it, okay, okay, it's just this entity. Okay, if I look at it, okay, expand. Okay, this is one entity. I'm checking this. It's just finding the value. It's based on the name. Okay, if you look at this, if I look at the details here, you see this entity will be expand. It's Jarasandha is what we have selected from the Mahabharata, and it do it. Okay, let's select some other entity. Okay, so currently this is under the particular filter of this particular display name. Okay, so this is how currently we not done any mapping, but it okay. Let's try out something like this. Okay, here I come here, search for search ID, metadata. Okay. So let's add something called Krishna. Okay, so if I add, check it. So it has all, it is just whatever the entity, the name, it is relevant to this one. You have it. If you click on it, if you click on a detail plan, if you click on the detail, it'll tell you this is where the data is loaded from. Okay, and if you have a relevant to multiple documentation, it will, if that contains this particular value or Krishna, it will do the entity recognition and do this one. Okay, so you can see these are the text we have. These are the 11 we have: Balarama and fourth day, Karna, Bhima, all those things. Wherever the document number is there, it exists there, it is sharing it. Okay, let us clear this one. Let us select something else. Document ID. Okay, let us select a different document ID. Okay, this is a document ID. I want to add up. So let us see what is this about. Details. It's a lot of the rings. Okay, so if I go and select some value. So detailed plan. Okay, so you can see the neighbors for this one. Okay, if I go and then this is just a, we are using a Graph Explorer. It is using a Cipher. Okay, you can see this one. It is using a Pro Open Cipher to connect to this one and giving this. We have this many nodes and this many edges. Okay, 3.51K, and from there we have edges like this. Okay, here we are checking on this. Okay, let's try something. Okay, so we are here. Now we have an entity. So entity, the most of the entities I can select, let's say, Bill Sam. If I click on it, so you see this one, Sam Gamgee is there. If I click on Sam Gamgee, it has, okay, let's say if I click on the Sam Gamgee from the Lord of the Rings, if I click on a detail and explore this one, expanding the node, wait a minute, expand the panel. Okay, it's expanded it. And then it can see what is the details we have. Okay, set Frodo with the smooth we didn't discuss. So this is just a Travis. Okay, if he says Samjamji, what he spoke to other person, it will check each chunk what context it has, it summarize and give you the response. Let's come to our data from our knowledge base. Okay, so select the model. Again, I'm selecting the Nova Pro. Okay, I'll ask overall part of fellowship offering. So, but this is the detail it has. If I go to the chunk, it is checking that particular document and it is going to that particular vector database and get it. It is saying that philosopher of Frodo, Sam, Merry, Pippin, Aragorn, Boromir, Legolas, Gimli, and Gandalf. Okay. What is the relationship between Frodo and Bilbo? Just run it. Okay, this is happening frequently. Let's see, clear this. Our cousin, close family bond. Um, do Gimli's relation to Frodo? Sorry, I can say Bilbo. Okay. No, indeed. Okay. I'm just asking, what about Frodo? However, this is completely hallucinating. Okay. Okay. So let's go for one more use case. Okay. Tell me about some financial Ponzi scheme. Okay. So Bernie Madoff Ponzi scheme infamy. Okay. Here I'm asking who brought this scam limelight? Okay, I'm getting a feedback. It may be a little bigger one. Who bought this scam limelight? Harry Markowitz is a whistleblower and financial analyst. Okay. And what is the relationship between Harry and Madoff? Okay, so you can see the meta associated with this. This is the metadata. It travels. I tried the same, so you can see this is the data we have. And tell me the list of people involved in the scam and their relationship between them in bullet points. Okay, let's see what it'll do. Benny mastermind, okay, Ruth Madoff, Benny's wife, okay. So this response will be faster since it is traversed through the graph and getting you the response. If at the same time, if you are using the text and it will go through the chunk and it's not able to, it can do it, but it is more optimized here. There are multiple options you have to multiple use case you can apply for this graph based knowledge, sorry, knowledge based for the graph rag. Okay, so this is about this one. Okay, I'm asking, is there any relationship between Gandalf and Krishna? Let's ask some questions. There's no direct, okay. If you look at it, it will go and look on both the chunk. Okay. So it will look on the both the chunk. Okay, this is check on the adjective and this one. See, this is what it's so quick. Okay, that's what okay. And what is the similarity of character between Gandalf and Krishna? Let's run it. Both character possess a divine and supernatural aspect. Okay. Okay. Wisdom and guidance. So this is taking out from the multiple documentation, sorry, multiple documents, and it is understanding the context and summarizing it. Okay, that's what I want to show you when I was giving a they want to add the Mahabharata and Lord of the Rings. I just want to find some common character. I find this just want to correlate how the graph rag will be uh, useful. Okay, when I click on this one, you can see the chunk one. I take this one and this, I take for this one. So it is just a chunk of details it is taken from. Okay, that's all I want to show you. But if you want to test a few more options, like come to the knowledge base, I'm going to touch upon few things using a different model. Let's see how it is faring against a different model. Select the model. So I'm going to select Anthropic, Claude, Sonnet, B1. Okay, US Anthropic, Claude, Sonnet. Okay, so come here, run this, and then I can see the same thing. Okay, I think something wrong with the model. Let me live with the Haiku, which is a quick model. I'm in a right database. Yes. Okay. Okay. So this is what you can see. Okay. So that's all I want to show you. Feel free to let me know if you, this is what the graph rag I want to show you. Just a quick recap. We have seen how to create the knowledge graph from here. You select the vector database, and while you are creating the database, rather than the open search, which is the default database, the vector will be stored, you are going to select the graph rag. And as simple as and for the data source, we are using S3, where from there we are taking a data source. And but the you can it will support multiple data source I mentioned, right? So click on it. So you can have a multiple data source. Even if you have a Salesforce, you can connect to it, and you can, if you have want to find the multiple relationship between your marketing, sales, based on your CRM data, GraphRAG. Again, it will be very helpful. And at the time, you can, the next one, the data source, then we have selected the vector store as a GraphRAG, and it automatically created the Neptune. As I mentioned, the GraphRAG, it is created the Neptune here. Then we use the notebook to explore this one. See how would the data got extracted and stored in the entity, and then it found out the relationship here while you are storing the data into the GraphRAG. Then while you are using the knowledge base and asking the question, it can, if it is it is spread across multiple documentation, it is find a similarity and entity, what is the common characteristics between them, and giving you the response. Okay, we have seen with the multiple documentation, it look at it and get the response using the GraphRAG. Okay, so that's all, guys. That's all I want to show you. Thanks for staying tuned for this today's session. And the next session soon we will come with evaluation or agentic AI, some interesting topics. If anyone want to know more about it, stay tuned with the DataOps Labs. Connect with us on the YouTube, and follow us on our LinkedIn, and follow the newsletters where any upcoming sessions we want to come and join us, we're gonna share with us. Okay, DataOps Labs, and please feel free to subscribe it. Okay, thanks, guys. Stay tuned. Looking forward for amazing session in upcoming weeks. Have a great day.